Ask your AI agent a question about your own business. Something basic. Say, what is our refund window? And watch closely. It says 30 days. It answers instantly, confidently, and completely wrong. It never opened your policy. It guessed from training data and handed the guess back as a fact. And if you have been using AI for you may know the fix already, RAG. RAG takes every document you own, chops it into chunks, turns each chunk into a vector, and stores it. And whenever you ask a question, it pulls the closest pieces and hands it to the model. RAG is genuinely powerful until you look at what it actually did. It shredded your clean, structured policy into fragments, grabbed the 3 that looked most similar, and threw away the order that made them mean anything. The answer is now a guess dressed up as a citation. But what if I tell you there's a second way? Recently, in June 2026, Google Cloud shipped OKF, the open knowledge format, curated knowledge written as plain Markdown files, and asked the exact same policy question as before. And the AI answers with 14 days and points directly to the original policy file, instead of stitching together fragments from a vector database. But let me tell you that OKF has its own ceiling though. Like, someone has to write every word of it. It's precise and trustworthy and auditable, and on its own, it will never cover a million messy, unpredictable documents. So here's the question every team is asking right now. RAG with its endless scale and fuzzy search, or OKF with its precision and structure? Which one do you bet your agent on? And I tell you that it's a wrong question. The answer isn't one or the other. It's both. The architecture that actually wins puts OKF and RAG together and takes the best of each. Let me show you a quick preview. A high-stakes question routes to OKF. Exact-cited. Done. An open-ended 1 routes to RAG. Search the entire archive. 2 layers of knowledge. 1 agent on top. OKF carries the canonical 80%. The answers you simply can't get wrong. RAG handles the long tail. The messy 20 you could never sit down and curate by hand. Precision and scale. Trust and reach. Structure and search. That's the hybrid stack. And by the end of this video, you'll know exactly how to wire it together. Let's build RAG properly, step by step. See, whenever a document arrives and it gets split into chunks, usually a few hundred tokens each. Most systems also overlap neighboring chunks a little, so important context isn't lost at the boundaries. An embedding model then turns every chunk into a vector. You can understand vector as a long list of numbers that captures its meaning. Alongside each vector, the system stores metadata like the source document, page number, or title, so it can always trace the information back to where it came from. All of those vectors get stored in a vector database. Then someone asks a question. The question becomes a vector too. The database compares it against millions or even billions of stored vectors, measuring which ones are mathematically closest using similarity metrics like cosine similarity or dot product. Under the hood, databases like Pinecone, Weaviate, Qdrant, Milvus, Chroma, and PostgreSQL with pgvector use approximate nearest neighbor indexes, so they don't have to compare against every single vector. That's how they can search billions of embeddings in milliseconds. The database returns the chunks sitting nearest to the question in that semantic space. Those retrieved chunks are then injected directly into the model's prompt, giving the LLM fresh knowledge without retraining. That's the real magic. It matches by meaning, not by keyword. Different words, same idea. And RAG still finds it. This grew into a whole industry. Pinecone, Weaviate, Qdrant, Chroma, Milvus, and PostgreSQL with pgvector all exist to store massive collections of embeddings and retrieve the right information almost instantly. This is the thing OKF can't touch. Raw, open-ended scale across everything you've got. But chunking comes at a cost. Split a table, a procedure, or a contract in the wrong place, and the context falls apart. The model gets disconnected pieces and starts filling in the missing gaps, which is exactly where hallucinations begin. And retrieval is probabilistic by design. It hands back what's likely relevant, not guaranteed the one correct answer. That's wonderful for a fuzzy exploratory question. It's genuinely dangerous when the exact refund window, the exact price, or the exact dosage is what matters, and it's a black box. Change one policy and you rerun the entire ingestion pipeline. You can't diff it in a pull request. You can't easily audit what the agent actually knows, and outdated chunks sit in the index long after the truth has moved on. Now on the other side, OKF takes the exact opposite bet. No pipeline, no embeddings, no vector store, just a folder of Markdown files with a little YAML on top. The spec says it best. If you can cat a file, you can read OKF. If you can get clone a repo, you can ship it. Each file is a single concept. The front matter carries a type the only required field, plus optional title, description, tags, a timestamp, and a resource field, a link pointing at the real underlying asset. Underneath is structured Markdown, headings, tables, lists. The kind of model reads completely, in order, with the structure intact, and concepts link to each other with ordinary Markdown links. Follow them and your knowledge turns into a graph. A table points to its data set. A playbook points to the table it repairs. Those are real semantic relationships, authored deliberately by a human who understood what they connected. And to mention, retrieval is deterministic. You decide exactly what the model sees. The structure survives the retrieval step intact. And the whole thing lives in Git, so you can diff it, review it in a pull request, assign an owner to every fact, and roll back a bad edit with a single command. If that feels familiar, it should. It is the sleuds.md file. It is the LLM wiki Andrej Karpathy keeps pointing at, context you engineered deliberately by hand, rather than indexed automatically at ingestion time. OKF's contribution is formalizing that pattern as one shared, open, vendor-neutral spec that any agent and any framework can target. Ask the same question, what is our refund window? And OKF answers exactly 14 days with a direct link to the source policy. Deterministic. Cited. So you build both and you put a router in front. A query comes in. Is it canonical and high stakes? Send it to OKF for an exact cited answer. Is it open-ended, exploratory, buried somewhere in the archive? Send it to RAG. Every query goes where it's strongest. The cleanest way to picture it is an 80-20 split. OKF is the spine, the curated, structured, high-trust core of what your agent knows. RAG is the reach, the huge, messy, unbounded long tail you could never realistically handwrite. Make it concrete. A support agent gets 2 questions. What's our refund window? That's canonical. So it hits OKF and answers 14 days exactly with the policy linked. Has anyone hit this weird billing bug before? That's open-ended. So it hits RAG and searches 40,000 old tickets. Same agent, 2 completely different knowledge paths, and the 2 make each other better. OKF gives RAG ground truth. When a curated concept exists for a question, the agent trusts that over a fuzzy retrieved chunk, and that single rule makes a real measurable dent in hallucinations. OKF also hands the agent a map. Its index files list what knowledge exists before any search runs. Progressive disclosure, so the agent drills into RAG only where the curated answer runs out instead of blindly searching from 0 every single time. And RAG gives OKF reach. Point semantic search at the bundle itself and at everything sprawling beyond it. Curation covers the critical core. Retrieval covers the endless rest. Neither one has to pretend it can do the other's job. And the best part, the agent doesn't have to care which is which. Put the OKF bundle in the vector index behind one retrieval interface, even a single MCP server, and the model just asks for knowledge. All the routing and plumbing stays hidden underneath. Now lay the scorecards side by side. Precision from OKF, scale from RAG, trust and breadth, structure and fuzzy search, get diff, and auto-indexed. For the first time, you stop trading one good thing away just to get the other. And the economics lineup, too. An OKF bundle is just text and get. Write it once, edit a line, done. RAG carries real running cost. Embedding every document, re-embedding it when it changes, and hosting a vector database that never sleeps, curate what's worth curating, pay to index the rest. So practically, when do you reach for which? Small, curated knowledge base where every answer is high stakes and has to be exact? OKF alone. Everything versioned, everything owned by a real human. Massive, unstructured corpus, contracts, support tickets, transcripts, mixed PDFs, where semantic matching is good enough for the job? RAG alone. Building anything serious headed for production? Both. The high stakes core goes in OKF. The long tail goes in RAG. A thin router in the middle decides query by query. Data owners curate the bundles. Engineers run the ingestion pipeline. LangChain or Llama Index wires the two together. The agent consumes both without caring which one answered. Now let's kill 2 myths. First, OKF does not make RAG obsolete. The moment your corpus is too big or too fuzzy to curate by hand, vector search wins, and it isn't close. RAG is not going anywhere. Second, no, you can't just dump everything into one giant context window and call it solved. Irrelevant knowledge actively degrades the answer and quietly burns tokens. Selective routed retrieval still beats brute force, even at 1,000,000 tokens of context. In the real world, this is a team sport. Data owners curate the OKF bundles. Engineers index the archive into a vector store. Frameworks like LangChain and Llama Index wire the two together. And an agent, Claude, ChatGPT, or Gemini quietly consumes both. And it's moving fast. OKF is only weeks old and already thousands of GitHub stars deep with agents, now starting to write OKF bundles themselves. Curated structure and raw retrieval are converging. Graph and vector authored and searched folding into one stack. So that's the whole picture in one frame, a router up top. OKF as the curated spine rag for the long tail. One grounded agent sitting above both. It was never OKF versus RAG. It's OKF plus RAG. If that finally made the AI knowledge stack click, do me a favor and subscribe, and I will see you in next one.